Hey folks, welcome back to this video. So right now, every user request hits my vLLM backend directly. It's fine until load will spike, but when that happens, then everyone will suffer. My latency will go through the roof, my timeouts will grow, and then my GPU will get thrashed. That's why in this video today, I want to talk about the adaptive inference router that I will be using. So it is a smart gateway that protects my GPU inference backend by classifying the traffic into different tiers, and it'll set excess load before it causes damage, right? So if you're new to my video, I kind of want to show where I am right now. So what I have is I have my local LLM running in vLLM pods. So this is my user interface. And then this is my Kubernetes cluster, and I have some Grafana dashboard where I monitor the matrix from GPU and vLLM, just to give you a high level overview. So this is the user interface that I have, and then that is the model that I will be interacting with. And these are my dashboards. For LLM, I have certain important metrics monitored, and then I have another dashboard for GPU monitoring where things like the utilization, temperature, and other key metrics are monitored. So going back to this adaptive inference router, right? So why do I need this, and what is this? So it's a Python fast API gateway that will sit in front of my vLLM, and then this will make this smart routing decision based on the real-time backend health matrix. So without this, what will happen is, too much traffic, everyone will suffer equally, right? But including this, I will be protecting my system by setting excess traffic before it causes any damage. So kind of the analogy is, think about how Anthropic serves as free and pro users on the same GPU fleet, right? When they have heavy load, then they'll throttle their free user traffic to protect the SLO of the paid user traffics, right? So as shown before, this is my current architecture. Any traffic that comes in from the user or from some load testing, all of this will go to the vLLM backend directly. So imagine if I get hit with 5,000 requests and it arrives with no gate in place, right? So then I'm looking at 20 to 40% performance degradation or even more, and increasing timeouts. Every user will get a bad experience. There's literally no way to protect anyone, right? But with the adaptive router, what I'll be doing is that I will be using my inference router logic that will check my vLLM API backend health, and based on that, I will make routing traffic decisions, right? So what we will do here is that my backend poller is not going to monitor every single request. It polls the vLLM API every 3 seconds. It gets the matrix from there, and then it will save all of those matrix in my cache, which I will use Redis for that. And then each request that comes in, a cache will be read. Based on that, we'll find out what situation we're in, and then a decision will be made, right? So for traffic priority, like, who do I prioritize? In case of Anthropic, they prioritize their paid users, right? But for me, I will prioritize my existing users versus new requests that'll come in, because for my existing requests, like, things are already being processed, right? So instead of kind of serving everyone, I'll try to prioritize my existing users. And for the new users, if my system is busy, I will give them in a 503, and I'll say that, retry again in a few minutes, right? So what are the metrics that my router will monitor? So this is this part here. This is my inference router. So what kind of matrix we monitor from the vLLM API, right? So we'll talk about that now. I will be monitoring three key metrics for now. This will increase or decrease based on how, like, how I will learn and how the system will behave as well. So we'll look at the number of requests that are waiting, and which will be the queue depth. I will see how many requests do I have in the queue. A growing queue means my vLLM is falling behind. And then I'll have my KV cache percentage. I'll see, like, how full is the GPU's KV cache. If it's more than 90%, then latency will spike. It will be hard to serve request in a in a proper time. And then I'll be looking at the time per output token. Like, how long does it take to output a token? If it takes too long, then customer will face slogging responses. So these will be the three key metrics I will be monitoring from my vLLM backend. So based on this metric, I will tier my traffic into three different categories. So it'll be green, yellow, and red, right? So as shown in this diagram, we'll have, if the traffic is green, yellow, and red, then three different decisions will be taken. So green will be a healthy state where I'll have less than 5 requests in my queue. My KV cache is less than 70%. In a situation like this, I will forward all of the requests to vLLM, but I'll set a max output token saying that it'll only be 512 tokens. So this is my normal full service scenario. That value can be increased to decrease. I just put it there for now. And then the other state will be yellow state, where we will have a degraded state, right? So this will be my flow if my queue depth is between 5 to 9 or my KV cache is more than 70%. We will still forward the traffic to vLLM, but what we will do is we'll limit the number of output token. So the users will still get answers, but it will be shorter answers. And this is the load setting state. If things are really bad, then we will be in the state where we have more than 10 queues and the KV cache is more than 90%, or it takes more than 100 milliseconds to serve the request. Then the users will get 503 straight away. It will say that retry after 5 seconds. So why do we go 3-tier instead of just 2 tiers, right? Allow or deny traffic. So that is too harsh. If you want something in production, let's say, like when we design systems for production, it's better to have graceful degradation when things get bad rather than doing a full failure. So something what Anthropic does as well, like free user will get short and small response rather than getting cut off entirely. It kind of gives a better user experience, right? So the next thing I want to talk about is SLO targets. We have to take this into consideration as well, because it's not about how many requests we serve. It's about the requests that we decide to serve. Did we serve them well, right? So the SLO targets that I like to hit from my application would be 95% of my admitted request should be served in less than 15 seconds. My error rate, not the 503 errors that I will be giving, should be less than 1%. And then I should not be setting more than 20% of my traffic. So that will be the SLO that I'll try to hit. So how do I meet this SLO? That's when auto scaling comes in, right? So I'll have a second GPU worker node that will be pre-joined in my cluster, but it will be in a tainted state. No pods will be running there. And if my worker node comes into pressure, it's being overloaded, it sees that SLO is being breached, then we will have a pipeline that will provision my second worker node, and then it will start the vLLM pod there. Then the load will be shared between two different nodes, and both of them will be serving the traffic. That's when our queue will drain and our SLO will recover, right? So just to reiterate on this again, we will see if we are breaching our SLO or not. So we'll have a pipeline or a Python loop that kind of checks if we are breaching the SLO or not. And if it's breached, then we will scale up. After we scale up, then the traffic is rebalanced between those two nodes. And once everything is back to healthy and a normal state, then we will take the other node out of our production and we'll taint it. So why is this important, right? This kind of shows that we are managing our traffic in different tiers. We are doing intelligent routing. We're doing like matrix-driven routing rather than just run-driven algorithms. We are meeting some SLOs. We have our SLOs that we want to meet and protect. And based on these SLOs, we are implementing our auto scaling. So we don't just scale because we want to scale. For our scaling, we check if our SLOs are being breached or not. After that, we have observability in our Grafana dashboard. So we'll monitor everything that's going in our cluster. So it'll give us a high overview of what's going on. And then instead of full failure, we have a graceful degradation of our service. That's how you would design things for production. And of course, I know there are many improvements that needs to go through to this as well. But, eventually I will be making further improvements. And in the next videos, I will be building this. So thank you so much for watching this video, and see you again.